All right, so we're going to continue looking at some trinomials. This time we're going to look at some of the what I call the harder trinomials because they have a coefficient other than 1. When they have that coefficient other than 1, then it takes away our shortcut of factoring. So either you have to do it by trial and error, or I'm going to show you another way to do it. You can do it by rewriting it as a grouping problem. Now, how you're going to start with that is you're going to multiply your first and your last terms together. So in this particular problem, when I multiply negative 3 times a positive 2x squared, I get negative 6x squared. So I'm going to be looking for two numbers that multiplies together to give me negative 6x squared, or adds together to give me my middle term of positive 5x. So think about that, and you can even go back and look at the shortcut that I gave you for talking about the shortcut that I gave you for talking about your signs in a trinomial. If the third sign is negative, then you know that one of your signs is negative and one of your signs is positive. So I'm looking for two numbers, one being negative and one being positive, that multiplies together to give me negative 6x squared and adds together to give you positive 5x. So what would you think? Negative 6x times a positive, and I'm just going to write the 1 there to show you, but positive 1x. Negative 6x times positive 1x gives me negative 6x squared, but when I add them, negative 6x plus 1x gives me negative 5x. It's not what I'm trying to do, is it? I'm trying to get a positive 5x. So when you get the right answer, but your sign is wrong, all you have to do there is to change your signs. So I'm going to want a positive 6x and a minus 5x. So we did all that work to come up with these two numbers. And what we're going to do is we're going to take our original problem and we're going to rewrite it. And that should be a 1. Okay. All right, so we're going to rewrite it. 2x squared minus 1x plus 6x. All I'm using is those two numbers. They're going to rewrite the 5x. The first and the last number stays the same. Now, when I was writing that, you might have noticed that instead of writing 2x squared plus 6x minus 1x minus 3, in the order that I had put them over here, I flip-flopped it. The reason I did that is because I've worked it long enough to know that in the grouping problems, when you have the negative on the third term, you got to worry about factoring that aggravating negative out. So I just went ahead and rewrote it because it doesn't matter in what order I write negative 1 and a positive 6x. When I add them together, I'm still getting that positive 5x. So just sort of like a hint, when you have the choice to where you put the one with the negative, make sure it's not on that third term. So what I've done is I've taken my trinomial and I've rewritten it into a grouping problem. So I'm going to group the first two and I'm going to group the last two. Here again, because of the way that I wrote it, on that last grouping, I don't have to worry about a negative. I'm going to pull out a GCF, which is x, out of the first two terms. That'll leave me with 2x minus 1. I'm going to factor out a 3 out of the second grouping. That's going to also leave me with 2x minus 1. And again, if you're making common mistakes, you can show that I'm dividing the first terms by x. I'm dividing the second terms by 3. Remember with the grouping problem, what's left inside parentheses should be the same. So I'm going to factor out the 2x minus 1, which means I'm dividing both of these terms by 2x minus 1. And what does that leave me with? X plus 3. So the factorization of 2x squared plus 5x minus 3 is 2x minus 1 times x plus 3. Now remember, it doesn't matter the order that I write these. In other words, x plus 3 times 2x minus 1 is, of course, the same answer. What would not be the same answer is if you had incomplete signs or incorrect signs. Instead of 2x minus 1, you put 2x plus 1. That would be wrong. Okay, so to give me a little bit more room to write 26, I'm going to use the eraser. And I'm going to get rid of this to give me some room to work the problem. Okay, let's look at another example of a harder type of trinomial. Again, I have that 3 in front of that x squared. So I look for two numbers that's going to multiply together to give me my last term of negative 5. Oops, that is not correct. Thinking more about my handwriting than the video. I'm going to multiply the first term and the last term together. So 3x squared times negative 5 gives me negative 15x squared. I'm going to look for two numbers that multiplies together to give me negative 15x squared, but adds together to give me my middle term of negative 2x. It's important on the harder trinomials that you include your x's when you're doing this, or else it will not come out correctly. Notice that my last term is a negative, so I know that these factors have to be one positive and one negative. So what two numbers multiplies together to give you negative 15x squared, but adds together to give you negative 2x? How about a negative 5x and a positive 3x? So what we're going to do is we're going to take those two factors and we're going to replace it with the negative 2. So that's 3x squared minus 5x and a positive 3x. We're going to replace those two factors. And if I add this together, negative 5x and 3x does give me negative 2x. I haven't changed my problem. I just rewrote it in a different way. I rewrote it so that I have 4 terms. So I'm going to group the first two and I'm going to group the last two. So I'm going to take out an x. That leaves me with 3x minus 5. I do not have a GCF between 3x and 5, so I'm going to write this step. What I really have is the GCF is 1. So if you don't have a GCF between those two numbers, your GCF is actually 1. Still works out. I have 3x minus 5 in both of those, so I'm going to factor that out, and that's going to leave me with an x plus 1 as my second binomial. So that's an easy way of factoring harder trinomials. You're going to rewrite it as a grouping problem. My favorite probably of factoring is the difference of squares. They are very easy if you know your perfect squares. So if not, go back to that rules of factoring and look at those perfect squares and learn those. Perfect squares, 2 sets of parentheses, plus minus. X squared breaks down into x and x. 144 breaks down into 12 times 12. Now, as I'm doing these, remember, I'm just showing you how to do the difference of squares. I'm not concerned with GCFs or being able to break it down further. We'll address that in just a second. All right, so look at this, 36, x squared, 49, and y squared, they're all perfect squares. So 2 sets of parentheses. What do I square? let me go ahead and put my signs in there. Difference of squares are always plus minus. 36x squared is 6x and 6x. What do I square to get 49? Y squared, 7y times 7y. 46, those are all perfect squares, so 2 sets of parentheses. Plus minus, what do I square to get x to the 4th? That would be x squared times x squared. What do I square? 1 and 1. Now, here's the situation we're going to run into when we start putting all of this together. I broke down this into a difference of perfect squares, but one of the remaining factors also happens to be a difference of perfect squares. Both x squared and 1 are perfect squares, so I'm actually going to be able to break down that further. What about this x squared plus 1? They are perfect squares, but they are sums of squares. And remember, sums of squares are prime, so I'm not going to be able to break that first bracket down. But it's still part of my answer. I'm just going to bring it down, and then I'm going to factor x squared minus 1. 2 sets of parentheses, plus minus. What do I square to get x squared? X and x. What do I square to get 1? 1 and 1. That is my complete answer. Yes, I guess I am a nerd because I like the sum and cube problems. Now remember, sums and cubes, difference in sums of cubes can be factored, unlike that of squares, where the sum of squares is prime. I can factor the sum and difference of cubes. You can see that x to the 3rd is a cube and 27 is a cube. So, to factor the cube problems, one binomial, one trinomial. My signs are same, opposite, positive. So the same sign that I have over here, negative. Opposite of that sign, so positive, positive. Same, opposite, positive. Then you complete the pattern. What do I cube to get x to the 3rd? X. What do I cube to get 27? 3. Then you square the first term, x squared. Multiply the two terms together, disregarding your sign. You've already put that into place. X times 3, 3x. Square the last term, 9. Sort of like hopscotch. Square it, multiply it together, square it. Let's try another one. This example is sum of cubes. Binomial, trinomial. Same, opposite, positive. What do I cube to get 8x cubed? That would be 2x. What do I cube to get 125? 5. Square the first term. So if I square 2 and I square x, I get 4x squared. Multiply the two terms together. So 2x times 5 is 10x. Square that last term. 5 squared is 25. And once you complete the pattern, you'll never be able to break it down any further. Okay, let's see if we can put all the rules of factoring together and factor these completely. Factor completely or state that it is prime. If I look at 66, I'm first going to see that I can take out a GCF out of that problem. The GCF is going to be 5x. So I'm going to divide both terms by 5x. So that cancels out. Remember, I'm subtracting these exponents. 3 minus 1 is x squared. 45 divided by 5 is 9, and the x's cancel out. That 5x that is your GCF is part of your answer all the way down. Do not lose your greatest common factor. But then go to the next part. Follow your rules. Count your terms. I have 2 terms. When I have 2 terms, it's going to be squares or cubes. So x to the second obviously is a square. 9 is a perfect square. So then I have to remember, how do I go back and factor the difference of perfect squares? So 2 sets of parentheses. My sign is always plus minus. What do I square to get x squared? What do I square to get 9? Always bring that GCF down. If you don't, your answer is incorrect. And the last rule of factoring is to go back and look and see if you can break anything else down. Well, I have 2 terms, but x nor 3 is either a square or a cube. The number of terms I have is going to let me know if I can break it down any further. So that would be my final answer. All right, let's look at 68. I see that 6, 18, and 60, first of all, they're even. I know I'm going to be able to factor something out, but I want the greatest common factor. What's the largest number that I can divide 6, 18, and 60 by? What if we try 6? You're going to see that I can't factor an x out because 60 doesn't have an x, so it's not going to be part of my GCF. So let's divide all of these by 6 and see what we have left. Those are going to cancel out. I get x squared minus 3x minus 10. This 6 is my GCF. It's going to be part of my final answer. I count how many terms I have remaining. It is 3 terms. If it's 3 terms, we have a trinomial. There are 2 kinds, easy and hard. The x squared does not have a number in front of it, so this means it's going to be an easy one. The easy one means that there's really no guesswork to it. I plug in my signs based on my trinomials. If the third term is negative, my signs are plus minus. How do I break up x squared? X times x. And the rule here is what 2 numbers multiplies together to give me my last term, this case negative 10, and adds together to give me my middle term, negative 3. So that would be a negative 5 and a positive 2. They multiply together to give me negative 10, but they add together to give me negative 3. So wherever you put the negative, the 5 goes with it. Wherever you put the 2, the positive, or the pause, wherever you put the positive, the 2 goes with it. And don't forget to bring down your GCF. Okay, 70 has a GCF of 7. So when I divide both of these by 7, I get x to the 4th minus 1. What remaining is 2 terms. It's squares or cubes. 4 is an even number, so it's squares. So I'm going to break it down into 2 sets of parentheses, plus minus. X to the 4th breaks down into x squared times x squared. 1 breaks down into 1 times 1. Be careful. Look at what's left. Can you break it down further? I cannot break 7 down. I cannot break x squared plus 1 down. It is a sum of perfect squares. It's prime, but I can break down this x squared minus 1. 2 sets of parentheses, plus minus. What do I square to get x squared? What do I square to get 1? Take a look at what's left. I have 2 terms, but neither x's are perfect squares. So I can't do anything else with that problem. All of that would be my final answer. Okay, looking at 72, I do not have a GCF that I could factor out of all 4 terms. I have 4 terms, therefore it's a grouping problem. So I'm going to group the first 2, and I'm going to group the last 2. Since there's a negative on that third term, remember we include the negative, we put a plus sign. And we're going to go back and we're going to factor the GCF out of each grouping. So if I take x squared out of the first grouping, that leaves me with x plus 3. I'm going to factor out a negative 25 out of the second grouping, and I'm going to show this step. I'm dividing both sides by negative 25, making sure that my signs are correct. Negative divided by negative is positive. That leaves me with x. Negative 75 divided by negative 25 is positive 3. Remember, with the grouping, I want to have left the same thing inside those binomials, which I do. So I'm going to refactor that out. So if I divide the first term by x plus 3, and I'm going to divide the second term by x plus 3, then these cancel out, and I get x squared minus 25. Here's a little unique scenario. You can kind of get caught up into doing the grouping method and go along without checking what you have left. What I have left shows me that one of those is something that has 2 terms, which are perfect squares, and it's a difference. So you're actually going to be able to bring that GCF of x plus 3 down and factor that x squared minus 25 into x plus 5, x minus 5. So you got to be really careful when they tell you to factor completely that you check your final answer. (78) does not have a GCF, but you can see that there are perfect squares. Our problem is it is a sum of squares, and we have to know that sum of squares are prime. So my answer to this problem is prime. You don't leave it blank. You must write prime. All right, let's look at 85. 85 has 1, 2, 3, 4 terms. So let me see what we can do here. If I try to go and factor an x out of the first grouping, I get x minus 12 because I have 4 terms. And it's just not working out. What in the world? This is kind of tricky. Honestly, I wouldn't expect you to get this right offhand without kind of having seen one before, because it's a little bit tricky. But when we try to go by our traditional methods of counting our terms, it appears that it doesn't work. But as you practice math a little bit, you're going to see more and more, not necessarily tricks, but different types of problems. So if I look here, this actually ends up being a trinomial that is factorable. And I know that because the more I practice with these trinomials, and I know that I'm factoring it in such a way that my third term is positive, so I look to the left, it's negative, negative. X squared breaks down into x times x. What number do I multiply together to get 36, but add together to get 12? That's 6 times 6. But another way that I could write that is x minus 6 squared. So I factored x squared minus 12x plus 36 into the trinomial that is x minus 6 squared minus 49y squared is the remainder of the problem. And even though it wouldn't appear that at first, what I actually have is a difference of perfect squares. X minus 6 is squared, 49y squared is squared. So to factor that, 2 sets of parentheses, I'm going to try to squeeze it in. Difference of squares is plus minus. What do I square to get x minus 6 squared? Well, that's x minus 6 times x minus 6. And what do I square to get 49y squared? 7y and 7y. So my answer is x minus 6 plus 7y and x minus 6 minus 7y. So that's a little bit tricky. The last one that I want to show you is how to factor out sometimes a fraction. What is the smallest number, 3/4 or 1/4? We both have an x in common, so I have a GCF. So we always take out the smallest one. So I'm going to take out x to the 1/4. So I'm going to write my GCF, and I'm actually dividing these terms, x to the 3/4 divided by x to the 1/4. That gives me x to the 3/4 minus 1/4. Same denominator, I keep it. 3 minus 1 is 2. So I get x to the 2/4, or reduces to x to the 1/2. So I get x to the 1/2 minus, what is x to the 1/4 divided by x to the 1/4? Well, any number divided by itself is 1. So don't let it trick you up if you're actually factoring out a variable who has a fractional exponent. Just remember at all times when you're dividing exponents, you subtract them and it makes it not too bad.